Concept number 12, European option pricing. So what is intrinsic value of an option, which is also called IV? This is the maximum of zero and the amount that the option is in the money. So this we have already seen that in case of a call option, the in the moneyness is determined by ST minus X, that is the spot price as on expiry minus the exercise price. And if it is not in the money, then the value of call option will be 0. And in case of a put option, the moneyness is determined by exercise price minus the spot prices on expiry, and this should be positive only if the spot price is less than the exercise price, right? In other cases, the value of put option will be 0. Concept number 13, factors determining the value of an option. So there are these factors which determine the intrinsic value of an option. The first one is value of underlying, right? This is very simple, that in case of call, the payoff is given as spot price minus exercise price, right? So if the underlying value goes up, then the value of call option will also go up, right? So there is a direct relationship between the value of underlying and the value of call option. And vice versa in the case of put option, because in case of put, the payoff is determined as X minus spot price. So if the value of spot price goes up, then the value of put will decrease. So there is an inverse relationship. So the same can also be understood for exercise price as well, right? From the given equation, it is inverse relationship with the call option and direct relation with the put option. In case of time to expiry, this is usually direct relationship in both the cases for both call option and put option. You can understand it this way, that the longer you get to exercise this right, the more should be the value of this option. Okay, the more the time you have in your hand, the better, right? So the more will be the value of option. This is also can be put in the form of an equation, that the value of an option is intrinsic value plus the time value. Okay, so intrinsic value is given by this equation. Time value depends upon how long the time duration to expiry. Okay, so the longer the time period, the more will be the time value and the more will be the value of the option. Then risk-free rate, it has a direct relationship with the call option. So the reason is very simple, that in case of a call option, there is going to be an outflow, right? On expiry, he will have to make a payment. Whereas in the case of a put option, the put holder will get to sell the underlying and he will be receiving some payment. Okay, so if the risk-free rate increases, then the present value of the inflow will decrease in case of put, right? So higher the interest rate, lower will be the present value, and that is why the value of put option will decrease. And vice versa in the case of call option, when interest rates are high, the value of call option will also increase. Then volatility has a direct relationship with the value of call option as well as put option. So higher the volatility, higher will be the value of call and put option. Talking about cost of carry. Now take it this way, that you have two options, either to buy a call or you can put your money in the underlying itself. Okay, and you expect the price of the underlying to go up. However, if you hold the underlying itself directly, then you will have to incur some cost. But if you hold the call option, then you can save yourself from this cost. So which is beneficial for you? You can still enjoy the rising prices by holding a call option and without incurring these costs, right? So higher the hassles of buying the underlying, higher will be the value of the call option, because this gives you relief from incurring this cost, right? So the cost of carry has a direct relationship with the call option, and inverse is the case with the put option. And the opposite is the case with the benefits. If you are not incurring cost associated with the underlying, then you are also not receiving the benefits associated with the underlying. So you are losing on this when you buy a call option. So that is why higher the benefits, lower will be the value of the call option, and vice versa. Concept number 14, lowest value of call and put option. Well, the explanation behind this equation is a very long and detailed explanation as given in your curriculum, but no need to get into all of that. You can simply remember this. The value of options is the difference between the exercise price and the underlying price, right? With the exercise price is denoted by X and the underlying price is denoted by S. So if we are talking about the underlying price as on today, then it is called S0. So this is the price as on today. However, exercise price is the price that needs to be paid or received as on expiry, right? That is at the end of time period T. So just to simplify it, you can bring this X to the present day value by discounting it with the risk-free rate for a period of time T. Okay, and the difference between the two is the value of your option. In case of call, it is spot minus exercise price. In case of put, it is exercise price minus spot, just that the exercise price needs to be discounted to today's value. This is not the exact explanation. I have given this just to help you remember this equation. Alright, so if you can remember this, then that is sufficient for you. Concept number 15, put call parity. This is the relationship between put option and call option. So for this, we have to understand what is fiduciary call. This is a long call combined with a bond when you go long. That means you have invested your money in a zero coupon bond and the face value of this bond is equal to the exercise price on the call. Okay, so in that case you will be receiving X at the end of the period. There will be no interest payments in between as it is a zero coupon bond. So these two combined gives us the left hand side of the equation, and on the right hand side we have the protective put, which is long put plus long stock means buying the underlying itself. So that gives us value of put plus the value of underlying. Now, what is the importance of fiduciary call and protective put is that the payoffs given by this side of the equation will always be equal to the payoffs given by this side of this equation. Okay, and that is proved here that at expiration, if the spot price is more than the exercise price, in that case the call will be exercised, right? It will give a payoff equivalent to ST minus X. Yes, so this C0 is giving a positive payoff. Then the value of the bond will also be received. The zero coupon bond will fetch X at the expiry, and combining these two we get a return of ST minus X plus X, that is ST. That is equal to the spot price at expiry. Okay, and talking about the protective put, since the spot price is more than the exercise price, the payoff for the put will be 0. The value of stock price as on expiry will be ST, and thus what you get in total is ST. So we see that on expiry the payoff given by fiduciary call and protective put is equal when spot price is greater than exercise price. Similarly, in case when spot price is less than exercise price, in that case too, the return generated by both the fiduciary call and the protective put are equal. So no matter what, whether the price goes up or down in comparison to the exercise price, the payoffs between these two fiduciary call and protective put are always going to be equal. And this is why it is called a put call parity. Okay, so here we put the equation for put call parity. Stock plus put is equal to call plus bond. Okay, so you need to remember this, that this is SP equal to BC. So what is the utility of this equation is that we can identify the fair value of any one element of this equation by putting in the value of the other three. Okay, and in any case, if this equation does not hold true, in that case the arbitrage opportunity will exist. So you can understand this with the help of this example here. Current stock price, that is S0, is 52. Risk-free rate is given as 5%. Price of 3-month put option with an exercise price of 50 is 1.5. Compute price of a 3-month $50 call option. So we are given with the variables for 3 inputs and we need to find out the value of the call option. So very simple, the value of call option shall be P0 plus S0 minus the value of the bond, right? X by 1 plus R to the power T. So just put the values. Value of the put option is 1.5. Then the value of the stock is given as 52 minus, what is the exercise price? 50 divided by 1 plus 5% to the power, this is for 3 months, right? So solving this, you get the value of call price to be 4.11. Concept number 16, arbitrage opportunity using put call parity. If the price of option is greater than the value that we have determined using the above model, in that case the option is overpriced and we need to sell the option. And in case the price of option that it is actually trading at, if it is less than the value that we have determined using the above model, in that case the option will be underpriced and we need to buy it. Okay, so let us see this with this example. Stock price is 60, that is S0. Risk-free rate is 6%. Call premium is 5.8 and put premium is given as 4.3. And we are asked that if there is an arbitrage opportunity. Very simple. Let us first find out the value of the call option using the same formula as we did earlier. That is the value of put plus the value of underlying, that is 60 minus exercise price, that is not given. Actually that should be $60 only. Okay, assuming it to be an at the money call option. So that will be 60 divided by 1 plus the risk-free interest rate, 6 by 12. And this gives us a value of 6.0228. Okay, so this is the value of call option as per our model. In the market, the call option is currently trading at 5.80. So this means that the call option is currently trading at a lower price, right? So the call option is cheaper in the market and hence the decision will be to buy this call option. So the arbitrage payoff will be 0.22. Similarly, we can do this for put option as well. In that case, the equation will be call option minus, okay, remember the equation is S plus B equals to B plus C, okay, and we are talking about P right now. So this S will be negative on the right hand side. So we can deduct this, then the value of the bond. So this equals to, the value of call is given as 5.80. The value of spot is 60. Then 60 divided by to the power 6 by 12. And this gives a value of 4.077. Okay. So this should be the value of the put option. However, it is currently trading in the market at 4.30. This means that the put option is currently expensive and hence we should sell the put option in the market. Concept number 17, synthetic strategies. The put call parity equation that we have seen just right now, that we have seen in the last concept, can be rearranged as we put the one of the elements on the left hand side in each of these case and keep the 3 elements on the right hand side. So the equation looks like this, and Okay, although you need not remember this, if you can just remember the put call parity equation, then you can form this right there in the exam itself. But this is important for you. You can be asked a question on this. Here you need to understand that what does the positive symbol means. Wherever it is positive, it means that you have to take a long position, and minus indicates that you need to take a short position. Note, whenever we are talking about put call parity equation, the exercise price for the call and the put must be same, and also the time to expiry should be same for this equation to hold. Concept number 18, put call forward parity. So this equation is similar to the one that we have seen in the put call parity case. The difference is just that in case of spot price, now we are using a forward price. In the beginning of this reading, we have seen this equation already, that S0 can be written as F divided by 1 plus R to the power T, right? So if we use this equation and replace the value of S0 with this, then what we get is put call forward parity equation. Okay, so just put the value of S0 in the put call parity equation, then what you get is put call forward parity. Okay, so mechanically speaking, the derivation of this equation is so simple. Okay, so this equation can again be established using the logical way also. Behind this, there are a few assumptions, like both the call and put options expire at the same time. X represents the exercise price. The options are European and based on the same underlying asset. Concept number 19, binomial valuation of options. This is very less likely that it is going to be tested in your exam. So if you are running short of time, then probably you can skip this part. You can skip this concept, okay? So far we have been computing only the payoffs from the options, but now we are going to discuss how the options are actually priced. Okay, so for this we have a binomial valuation model, and the formula for this is given as follows. The rationale behind this formula is that on the expiry, the value of stock, the value of underlying can either go up or it can go down, right? So if the value goes up, then the value of call option on that day can be represented by C1, and if it falls, then let's say the value of call option be C2. Okay, so these are the only two possibilities. Now we multiply it with the probabilities of each of these cases. Okay, and this probability is let's say P in this case, then it will be 1 minus P in the other. And this P is a risk neutral probability which is computed with another formula which is given by this. Okay, so if we just keep that aside, then this is a very simple and intuitive formula, right? The possible value multiplied with the probability, just add them up and you will get the value of your option. So let us understand this with the help of an example. So this company's stock is trading at $40. The value of an at the money call option on the stock, given that the stock can either go up by 60% or it can go down by 37.5%. So the currently the stock is trading at 40. It can go up by 60%. That means the value can become 64, or it can fall by 37.5%. That means the value can also fall to 25. Okay. So if the value goes up to 64, then what is going to be the value of call option? That will be 64 minus 40, that is equal to 24, right? Value of call option will be given by ST minus X, right? And in case of a downfall, the value is going to be 0 anyway. All right, so we have the value of C1 and C2. Now we just need to multiply it with the probability. So let us compute the probability here. So the probability is given as 1 plus the risk-free rate, that is 0.066% in this case, minus D divided by U minus D. So what is U and what is D? U means the upside potential, and the upside potential in this case is 60%, right? So this will become 1.6, and if this is the upside potential, and The downside potential is 1 minus 37.5%, right? So that gives us 0.625. So this is the value of U and D. Now just put it in the formula of probability. This is 1.6 divided by U minus D, U minus D. Okay. So solving this, we get the value of probability as 446. Now this is the value of P. So multiply this here, 0.446, and also this will be into 1 minus P. So although this will be 0, this is not relevant at all. And when you add these up, you will get the value as 10.1. This is the value of call option. Concept number 20, American option pricing. We have understood that American options can be exercised at any time at expiry or any time before that, right? And we have also understood that the value of a call option is given as ST minus X, that is spot price on expiry minus the exercise price, and in case of put it is X minus spot price as on expiry. Okay, so this is for call and this is for put. Now let us first talk about put. Since this option can be exercised at any point in time, we do not have to wait till expiry, right? So instead of writing T, I can say that I can sell it even today itself, right? So this can be replaced with S0, right? So the value of American put option shall be either X minus S0 or at the least it can be 0, right? And the maximum of the two will be the value of put option, right? So this is very simple and very intuitive. So we can apply the same logic to call option as well, and we can replace it with S0, right? And the minimum value can fall to 0. So this should be the minimum value of an American call option. However, we understand that European options has to be cheaper than American option, right? Because in case of European option, there is this rigidity that you cannot sell before expiry. But in case of American options, you get more flexibility and you can sell anytime you want. That means that American option, the value of American option has to be higher than the value of European option, right? But in case of while discussing the minimum value of an European call option, we saw that the minimum value of a European call option is given by this equation. So this means that the value of American option cannot be less than this, right? But if you see, then the value of this is going to be less than the value of this, right? Because when you discount X, then this figure will reduce, and as a result the value of this equation should be higher than the value of this equation, right? So in order to fulfill this criteria, we can say that the value of American option has to be at least equivalent to the value of an European option. And that is why in case of call option, we have replaced this equation with the value of European call option. Okay. And lastly, the effect of cost of carry on American call option. Very simple, that if there is some cost to be incurred in case of an underlying, then you will be delaying the call option. You will exercise the call option as late as possible. However, in case of put, you would want to sell it off as early as possible, and hence if there is a cost to carry associated with the underlying, then you would exercise the put early. Okay. Again, the opposite in case of benefits. If there are benefits associated with the underlying, then you would exercise the call option early so that you can receive the benefits, and vice versa in the case of put. Okay, so that means if there are let's say dividends and coupon interest associated with the underlying, then that will discourage early exercise for puts. So that's it for reading 46.